Welcome to the investigation for binomial theorem. The way we're going to investigate binomial theorem is through the Brazilian game Dois ou which I think everybody in the class is either Brazilian or has lived in Brazil for long enough that they've probably used Dois ou for their sports activities or whatever. The objective of Dois ou for those who may not have used it, is to try to take a group of people and quickly choose the desired number of people to be on a team or to be off the team or whatever. And basically the idea is to for everyone to throw out either two fingers or one finger, and if you're in the minority or if you're in the majority, then you either stay in or stay out, depending on what you want to do. If you want to eliminate one person, or if you want to choose one person, or if you want to choose two people or whatever, right? So it turns out that Dois ou is useful to understand binomial theorem, and we're going to go through some scenarios here, and then at the end we're going to talk about why this is related to binomial theorem. Okay, so first of all, we're going to look at the case of Dois ou, where you play with two people. And in this case, you probably don't do Dois ou for two people. You probably do something else, right? But if you play Dois ou with two people, D representing dois and U representing these are the four different ways, dois, 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 and that it might play out, right? And if we did something like we totaled up how many times you get, or how many ways you can get two doises, how many ways you can get two how many ways you can get one of each, then we would find out that the total is 1, 2, 1. There's one way to get two doises, there's one way to get two and there's two ways to get one of each. Dois or dois right? Now let's look at the three-player scenario. So in the three-player scenario, if we use the triangle to represent three players playing with each other, and we write the dois ou in the corner of each triangle, one of the ways that it might play out is dois, 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 and so we wrote dois, dois, dois in each corner. Another way it may play out is dois like that, with the dois in the top player, and then maybe the second player, I guess this is player 3 actually, gets dois and the other two are or maybe this player gets dois and the other two are right? These are all three different scenarios. Or maybe two players play dois and then the other player plays in which case you would have those two dois, or those two dois, or those two dois, and then one there. And then the last possibility is that all three players throw at the same time, right? Okay, so those are the 8 different ways that that you might get dois ou played out if you have 3 players. Okay, and then let's total up the different ways that we might see dois ou. So first of all, there's how many different ways are there to get dois, dois, dois? So that would be just 1, right? How many different ways are there to get 3 And that would be just 1 scenario also. How many different ways to get dois and dois So dois, or 1 dois and 2 there's 3 different ways to get that. And then what about for 2 dois and 1 There would be 3 different ways to get that. Interesting. So this forms a pattern 1, 3, 3, 1. The first one formed a pattern 1, 2, 1. Okay, let's go to the next scenario. The next scenario is 4 players, and with 4 players, you can get dois, 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 or, and then there's many other different ways you can get it. I would like for you to go ahead and do this on your own, and my advice to you is to make sure you kind of do it in an organized way. So remember that at the end, we're going to count up how many different ways there were to get 1 dois and dois etc. So if you organize them and put them all together, it makes it easier to at the end not repeat the same pattern or to not forget a pattern. Okay, so I advise you to kind of follow that pattern. Maybe you could follow this list right here, D4, D3, U1, etc. Okay, so I'm going to do it, and I'm going to pause the video. You go ahead and you do it. You pause this video, and then after you're done with the 4-player scenarios, come back and check your answer. Okay. Okay, I finished up. So basically, first I did the 4 scenarios where you have 1 dois and 3 ums. These are the 4 scenarios. Basically what I did was I took the dois and I rotated it around the square. And then I also have the scenario where I have 1 u and it goes around in a rotation also. So then I have 4 of those. So I know that there's one way to do with 4 d's. That's that one there. And with 1 d and 3 u's, there is 4 ways to do that. 1 u and 3 d's, there's 4 ways to do that. And of course, to do 4 u's, there's only one way to do that. And then now for 2 d's and 2 u's. So if you do 2 d's and 2 u's, let's see, first I put the 2 d's there, then I put the 2 d's there, and then I put the 2 d's there, and then I put the 2 d's there. And then I put the d's in diagonal and the other diagonal, and there's 6 ways to do that one. Right? So my new pattern is 1, 4, 6, 4, 1. Finally, let's do the 5-player scenario. Okay, the 5-player scenario, definitely try to be organized, okay, and try to group your patterns together. So go ahead and do that. Come back when you're done, and I will do it here, and I'll stop the video, and you pause the video too. Okay, so I finished my 5-player scenario. And basically, there is one way to have 3 d's, or 5 d's, sorry. There is one way to have 5 u's, and to have 1 u only, there's basically 5 ways to have that. We just rotate the u around the pentagon. So there's 5 ways to have 1 u and 4 d's. And then likewise, there's 5 ways to have 1 d and 4 u's. We just rotate that around the pentagon. That would also be 5. Now for the challenge. So to do 2 u's, we could put the u's, let's see, 2 u's here, 2 u's here, and we could rotate it around. Okay, and then we have a scenario where we separate the u's like that, and then we rotate that around. Okay, so there's total of 10 ways to do that. So with 2 u's, there's 10 ways to do it. And then to have 2 d's, exact same thing, right? So you have 2 d's, we rotate it around. Then we put d separately, rotate that around. So there's 10 ways to do that too. So the new pattern here is 1, 5, 10, 10, 5, 1. So our patterns were 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. And those of you with a good math memory maybe already can see where I'm going with this. Let's open up a different sheet. Okay, so here let's make the connection from dois to binomial theorem. Okay, so let's say we have 3 people. I made 3 people right here, person 1, person 2, person 3, and they all have the possibility of throwing either or dois when they play the game. And so what I'm going to do is I'm going to make a little representation here of all the possibilities of how they would throw umo dois, okay? So like one of the most obvious ways is that they might all throw So I'm going to put u versus u versus u. Or they might throw u versus d versus d. Or they might throw d versus u versus d. Or they might throw d versus d versus u. Or they might throw d versus u versus U. And what do I mean by this? I mean the first person throws D, the second person throws U, and the third person throws U, right? Or they might throw U versus D versus U. Or they might throw U versus D. The only combination I haven't written yet is if all of them throw D. That would be or D versus D versus D. Now, doesn't what I look like kind of look like multiplication addition? What if I simplified this and I used exponents? So U cubed plus UD squared plus UD squared plus UD squared plus DU squared plus DU squared plus DU squared plus D cubed. Now what if I group these? U cubed plus 3UD squared plus 3DU squared plus D cubed. Then I'm going to change my U's and D's to X's and Y's. X cubed plus 3xy squared plus 3xy squared plus y cubed. Then I'm just going to change these orders because they're kind of out in order. Usually we put the x cubed next to the, I'm sorry, this is 3. I wrote this, what is it? This would be x squared y, right? Because u is x and d is y. And what do we have? We have binomial expansion, the binomial theorem. So basically, if you have x and y times x and y times x and y, if you do a megafoil, what you're doing is you're choosing one, either x or y, from each one of these people, grouping them together and adding them up, and then you group like terms, and then you end up with the pattern 1 3 3 1, 1 4 6 4 1, 1 5 10 10 5 1. That, remember, is Pascal's triangle. And that's the reason why it's Pascal's triangle. We can build Pascal's triangle just by thinking through 2 or 1.